Hi, today I'm going to introduce Docker and Kubernetes. So first, introduction to containers. So virtualization is a process to virtualize a system resource like RAM, CPU, and networking, and represent them as multiple resources. So the key difference between containers and virtual machines is that VMs virtualize an entire machine down to the hardware level, but containers only virtualize software layers above the OS level. So normally it is faster than VMs. So what is a Docker? So Docker is a container provider developing, shipping, and running applications. It also allows for automatic container creation from your code, which is a Docker file. And the key features include Docker Engine, Docker Hub, and Docker Compose. And what is Kubernetes? Kubernetes is also known as a K8s because there are literally letters between the K and the S. And Kubernetes is an open source system for container orchestration. It automates the deployment, scaling, and operation of multiple application containers within the cluster. And it handles workloads with automatic bin packing, self-healing, and scaling. First, we start with Docker. To install Docker, normally we use Docker Desktop for Windows and Mac OS, and Docker Engine for Linux. So just basically follow the official installation guide for troubleshooting. And here are some common Docker commands which involve Docker pull, Docker run, start, Docker ps, stop kill. And more of these commands can be found in the cheat sheet from Docker documentation. So to build a Docker image, first we have to define a Docker file, which is normally a YAML file, to define the build steps. For example, here we have a simple Docker file. So the from command set the best image to a slim version of Python 3.8, which provides a lightweight Python environment. And a copy command copies all the files from the current directory, which is where the Docker file is located, into the app directory inside the Docker image. And run pip install is to install the Python packages specified in the requirements.txt file. And the command line is to specify the command to run when the container starts. So for example, here it runs the Python script app.py. And to create the image, we can run docker build my app in the terminal. And to run the container of the image, we can run the command docker run my app. And next up, the Kubernetes. So to set up a Kubernetes, we can install Minikube or Kind, or just simply enable Kubernetes in Docker Desktop for local Kubernetes cluster. And normally we use kubectl command line tool to interact with the cluster. And we can verify our setup of Kubernetes by kubectl cluster info. And here are some Kubernetes concepts. So first, pod. So pod is the smallest deployable unit. So it normally contains one or more containers inside the pod. A node is a worker machine in Kubernetes, so it can either be a VM or physical machine. And cluster is a set of nodes that runs containerized application. And deployment, it maintains the desired state of pods. And service is the abstraction to expose applications. Normally it is about networking. And namespaces are multiple virtual clusters on the same physical cluster. To deploy into Kubernetes, first we also have to write a definition YAML file. For example, here we have a pod definition template. So we will define the API version, the kind, metadata, as well as the spec. And we use kubectl apply file and also specify the file name to deploy the pod. And we can verify our deployment with kubectl get deployments or pod or service depends on what kind of a component that you're trying to deploy. And the detailed info can also be found with kubectl get deployments or describe deployments in the name. For example, here we have the kubectl get pod. So we have exactly 2 pods running. And this is a screenshot for kubectl describe pod and the pod name. So here we can see even more detailed information about the single pod. So next is a demo. So in this demo, we will try to Dockerize a simple Node.js web application and then push the image up to Docker Hub and then pull down the image from Docker Hub to local. And finally, we will deploy the container of the image to a Kubernetes cluster. And there are two prerequisites for this demo. First, you must have an account on Docker Hub. And next is the Docker desktop installed should be with Kubernetes enabled. So here we have our Node.js application, and this is our Docker file. So we'll build our Docker image based on the Docker file. So first we type in docker build t and your Docker Hub username and the image name. Okay, so now the image is built and we'll try to push the image onto the Docker Hub. So docker push and your username and the image name. Okay, so now as it's done pushing onto our Docker Hub, we can get on our Docker Hub to check whether the image is there. Here, as you can see, we have pushed our image onto our Docker Hub account. And here we can see some of the specifications of our image. Now we'll try to pull the image back again from Docker Hub. So first, let us delete the local image first. So docker remove image. Okay, so now the image has been deleted, and let us pull the image. Yeah, so the image has been pulled. Now that we have our Docker image on the Docker Hub, we can try to deploy the image onto the Kubernetes cluster. So here we have a YAML file which basically defines a deployment as well as a service. So in the deployment, first we define the image that we want to use and the name as well as the port, and also the replicas, basically how many pods that is going to be running on this image. And for a service, it is the pod related configuration. So having this file, we can run our kubectl and apply file express YAML. So it has now created two different things. So the first is our deployment and the second is our service. So when we see a kube control get pods, it has exactly 2 pods because this is what we defined in our YAML file. So kube get services. As you can see, our newly defined service is here, so it has its cluster IP as well as the port. Deployment. And this is our application deployment. Okay, so now if we want to access our web page locally, we can port forward our localhost port 8080 to the node port 80. Okay, so now on the browser, if we type localhost 8080, it will show our web page here, which means that our image has been successfully deployed on our Kubernetes cluster. So the key takeaway of the tutorial is first, Docker roles is to containerize applications, and Kubernetes role is to orchestrate the containers. And here are 2 recommended YouTube courses for you if you want to learn more about Docker and Kubernetes. And that's all for the tutorial. Thank you for your time.